Again to Let's Talk Forensics with Pastor Dan. Today we're looking at explosions. Yay, explosions. Explosions are defined as substances that undergo a rapid oxidation reaction with the production of large quantities of gas. Now, in addition to everything else that I discussed here, the other thing that needs an explosion to take place is confinement. So taking those gases and pressures and holding them in, that makes the explosion has more of an effect. Now, there are some additional things we need to identify explosions. It deals with a sudden buildup of gas pressure that constitutes the nature of the explosion. Again, confinement causes a lot of that. And second, the speed at which explosion detonates permits the classification of high or low yield explosives. There are two types of explosion, high yield and low yield. All right, now the simplest form of explosion is black powder. Black powder is a combination of 3/4 of the concentration is potassium nitrate, saltpeter, some carbon, 3/20 carbon, and then 1/10 of that is going to be sulfur. Those things added together with other components you want to put in there give us the generation of black powder, and in that way, when we confine it, we get an explosion. Now, again, we might talk about a low yield and high yield explosive. Low yield explosions, sorry about that, it's the reactions that go through a deflagration. That is a Latin term that means burning in a confined space. So when we try to make something burn but hold it in and then allow the reaction to take place, that's called a low yield explosion. High yield, on the other hand, is a reaction that goes through a detonation, an actual process shock wave that produces a sonic shock wave in that way. All right, awesome. Now, forms of low yield. There are two main forms. First is called the chlorate mixture. Okay, this is basically black powder, and you can tell it by the color that we have here. And you'll notice there's no like gaseous waves on the outside because of the fact that it's all that burning process that's going on there. The second is a gas-air mixture. So gasoline, other volatile liquids, compressed and contained. A fuel-based explosive, and you can see, first of all, a shock wave being generated, it's a little more forceful, and that is a result of the gases that are being produced, the vapors being lit on fire. All right, now, forms of high yield, there are again also two main ones. Primary, and a primary explosive is that reacts to heat, shock, or reaction, friction, so you could light them on fire. So stuff like nitroglycerin, primary cord, things that we could use to set off other reactions. And then secondary is explosive that only reacts when initiated by a prior explosion. The main example of that is if you've ever played games like Call of Duty, C4. Now C4, you can actually bang on it, hit it, smack it, try to light it on fire. It won't go off. The only way to make it actually go is to have another explosion take place inside of it, and then it detonates in that way. All right, now, when it comes to explosions, the entire bomb scene must be searched. What are we looking for? Detonating mechanism. A lot of times, bombers will use the same method of detonation. So if we can find what set the bomb off, then we can try to put that together, build a profile, things along those ways. Second, foreign substances that relate to the bomb. So one of the things that I took a group of students down to Waynesburg College, where they had a forensics day down there, and they had members of the ATF. And they said what they'll often do is they'll fly in like maybe a piece of PVC pipe. And maybe on the PVC pipe there is a barcode. And then they can scan the barcode and find out where that was purchased, start looking for videotapes from the store, see if they can identify who bought the material. Now, when it comes to the scene itself, often a crater is located at the origins of loose and other debris, and that must be analyzed. The soil itself has to be looked at. Secondly, objects located at or near the origin of the explosion must be collected. What we do when we have an explosion, we take all the parts and we reassemble the bomb as best we can. Back when they had the pipe bomber during the Olympics in Los Angeles, those things that we can identify in that way to be able to match up the scene. Now, there are two ways that we can analyze the material. The first is high tech. It's called an ion mobility spectrophotometer. It scans the material by scanning or sniffing the substances. I have two examples from my experience that I can speak to. The first took place when we were coming back from up in Quebec, Canada. We stopped off at the border. And before you go in there, they have you stop ahead of time, and I hear some puffing songs. So I sort of knew that this is what this was. And so I talked to the border agent, and I asked him about it, and I said, well, how sophisticated is this sniffer and this sensor? And he said, well, I can tell you exactly what medications you have and what dosage. So it's pretty sophisticated. There's another time, I took a group of students to New York City, and we went to the Statue of Liberty. When we went up the statue, before we went up there at a security spot, they had you run through an ion mobility spectrophotometer sensor. And they puffed me, and I said, oh, well, have you ever caught somebody in here with anything suspicious? He said, yes, sir. So what was it? He said, dynamite. I said, really? What did you do with him? He said, arrested him. Apparently some guy thought he could get through there, and he couldn't. And he didn't set off the bomb, so good for everybody involved. But those kinds of things, really sensitive. What they do is they blow air in it and they suck it out, and then they run it through a spectrophotometer and identify the presence of any drugs or explosives in that way. Now that's high tech. Low tech are these guys, canine dogs. They can be used because of their keen sense of smell. When a dog smells explosives, they don't start barking because some of that could be shock resistant. It can be, so that little barking sound could set it off. So when they smell explosives, they've been trained to kneel and sit exactly at the spot where the explosives are located. And then this is different types of tests we can do to find explosives. The devices we can use, HPLC, which stands for high pressure liquid chromatography. When I was in college, we tested various forms of caffeine with the HPLC. In reality, you need to know that of all the different types of caffeine, there's actually more caffeine in tea than coffee. But the reason why we drink coffee at a higher coffee at a higher concentration, that's why it gives us more of a kick. TLC, we talked about before, thin layer chromatography. GC, we talked about that one before. And our good old friend mass spec, but we'll also do x-ray examinations, especially if the bomb hadn't been set off yet, so we can examine what's involved there, and microscopic examination. So taking the parts, looking under a microscope, see if they can identify. All right, that's it for the notes on explosives. Hopefully it's not too bad. Take care. God bless.